Respected judges, Assalamu alaikum. We are Team TMV Tech Titans participating in Teknofest 2026 Technologies for Humanity competition. And today, we are proud to present Project TPF, our tactical pathfinder and finder UAV system. My name is Mohammad Arsul Ishan and I am joined by my teammate Muhammad Moitful. Firstly, let us examine our project scope. Severe natural incidents trigger communication dropouts and landslide blockages, leaving trapped survivors facing fatal exposure risks. Project TPF deploys an autonomous aerial microvehicle equipped with a radiometric thermal sensor, edge AI inference layers, and a robust acoustic bridge. Our system ensures zero ecological ground footprint and an unstable terrain, while accelerating ground rescue crew dispatch speeds by over 70%, providing direct access to vital assessment data within moments of the incident.
Our primary purpose addresses critical search workflow gaps. Traditional ground lines of slight fail entirely in thick foliage or severe atmospheric dust. Our social significance lies in establishing immediate bidirectional communication channels before physical clearance begins. This crucial step preserves victim physical stability, prevents post incident panic or shock conditions, and secures localized clinic triage information. We optimize the golden hour time allocation, completing search, active triage, and handoff cycles effectively using standard off the shelf carbon composites and accessible processors.
This brings us to a problem definition. When disaster strikes forested terrain, structural canopy density acts as a massive physical shield. Standard RGB optical cameras degrade immediately across environmental challenges like thick canopies, smoke, and whiteout conditions, leaving the ground below completely hidden. Ground-based search efforts inside these areas are extremely slow and dangerous due to fallen trees and debris. Our environmental opacity chart shows while optical and standard thermal sensors fail, our radiometric long-wave infrared systems combined with artificial intelligence maintain high classification performance inside these severely occluded zones.
Continuing our problem definition, we face signal and navigation barriers. Commercial GPS drones operate using raw satellite telemetry, but structured debris and thick overstory canopies severely weaken these signals. The GPS dropout's consequence leads to a complete loss of autonomous trajectory correction on conventional flight controllers, causing crashes, spinning propellers, generate persistent sound pressure levels exceeding 85 decibels. This acoustic mask completely prevents victim screams from being heard and breaks bidirectional speech, resulting in an unfiltered speech transmission index near zero during traditional drone approaches.
A proposed solution operates through a three-tiered autonomous sequence. When deployed, Project TPF bypasses external GPS requirements using autonomous LiDAR SLAM guidance. Phase 1 is the Scout, using radiometric AI to detect human body temperatures through thick foliage. Once a human pattern is matched, Phase 2 is the Guardian, where the platform hovers, triggering a 110 decibel acoustic siren and flashes high-intensity LEDs to anchor the survivor. Finally, Phase 3 is Triad, opening a bidirectional noise filter voice bridge using active noise cancellation to filter out rotor wash and accessing vital stats.
The scientific foundation of our sensing relies on Planck's physics model and Wien's displacement law. A human body at 37 degrees Celsius exhibits a peak emission wavelength near 9.3 micrometers. This places the strongest thermal emission squarely inside to 8 to 14 micrometer window that our long wave infrared detector is explicitly tuned for. By calculating the absolute per pixel temperature, our system avoids false positives. In daily life applications, this technology directly integrates into civil emergency rescue trucks, allowing local response crews to launch immediate search runs without waiting for state aerial assets.
Our system pipeline connects to four core modules. Firstly, the sensing module utilizes the radiometric microbolometer and optical flow. Secondly, onboard autonomy handles the edge AI classifier and SLAM 3D mapping. Third, the action payload controls the 110 decibel siren and duplex active noise cancellation order. Finally, the network relay maintains a decentralized sub-gigahertz mesh link, allowing one operator to manage a swarm of 5 units. The operating system is fully designed using parallel nodes within the robot operating system to environment. This node architecture guarantees fail-safe parallel processing across uncooled sensor elements while managing a low-density, high-stiffness carbon composite chassis.
Our prototype sizing targets a precise subsystem mass budget. The frame utilizes 28%, the battery 26%, the thermal sensor 16%, and compute nodes 10%. Our working method spanned a 14-week build across three phases. Phase 1 focused on thermal sensor calibration and false positive filtering. Phase 2 covered SLAM navigation, autonomous flight logic, and obstacle mapping. Phase 3 will be concluding with payload integration, specifically tuning our active noise cancellation, audio clarity, and stress testing the voice over IP system for optimal field deployment.
Our commercialization potential heavily outpaces conventional search rooms. While typical search rooms rely on optical feeds and one pilot per unit, TPF uses absolute per pixel thermal AI, autonomous SLAM, and allows one supervisor per 5 unit swarms. We sustain profitably through a recurring software license model for automated AI thermal dataset updates. Programmatically standardized quick release rails allow instant conversion from communication payloads to medical delivery pods or gas detectors per se. Sustainability is anchored in a modular lifestyle, ensuring a 10-year lifespan, linking swarms to off-grid solar charging nests for persistent zero-emission wilderness monitoring.
As for our target audience demographics, first we reach out to national disaster management directorates like AFAD that require rapid, deep foliage research platforms in remote areas. Second, civil protection and forestry sectors, including alpine rescue groups, operate in high elevation, GPS denied ravines. Third, international humanitarian NGOs such as Red Crescent acting in regions with severe infrastructure deficits.
The extended impact of Project TPF completely revolutionized search labor hours. A single TPF drone cuts this to 6.5 hours, while a 5 unit swarm completes it in just 1.5 hours. Our digital active noise cancellation effectively filters rotor noise, preserving 75% speech intelligibility. Furthermore, our swarm coordination drastically lowers carbon emissions by replacing high fuel burn helicopter operations with an all electric, zero emission autonomous drone networks.
Work package one handled AI model thermal signature calibration from weeks 1 to 3. Work package 2 covered onboard SLAM pathfinding and navigation. Trials from week 4 to 7. Work package 3 just achieved duplex audio rig integration in weeks 7 and 8. And finally, work package 4 is set to finalize active digital noise cancellation validation by weeks 9 and 10.
Our strengths include complete GPS denied navigation using LiDAR SLAM, low latency thermal classification at the edge, and an intelligent 110 decibel beacon with 24 decibel active voice suppression. Our weaknesses acknowledge a limited 45-minute continuous flight ceiling and a high battery weight penalties from ruggedized software. Opportunities exist in the direct software API integration with national crisis networks, payload swaps for medical drops, and cost reductions as thermal sensors scale globally. Finally, our threats involve localizing atmospheric winds exceeding 45 knots, dynamic unmapped forest anomalies, and supply chain limitations for specialty high capacity battery units.
In conclusion, Project TPF acts as the ultimate aerial guardian by executing autonomous deep foliage searches and filtering out rotor noise for direct communication. We are successfully helping others, bridging the golden hour, saving lives from above. This is Team TMV Tech Titans signing off. Tashakkur Ve Allah Hafiz.